Hi guys, we're going to be talking about converting units, which is another way of saying dimensional analysis. In chemistry, we use dimensional analysis because it's not always necessarily units. It could be moles or any amount of substance that we need to measure. So this first slide is just kind of some background information. You don't really need to write it in your notes. It says often a measurement is more convenient in one unit but is needed in another unit for calculations. Dimensional analysis is a method for converting units. You may have learned another method of converting units in math or in previous science classes. Trust me, learn this one now. It will help you solve many other chemistry problems later in class. So when you hear my juniors crying about moles and titrations, this is usually what they're crying about. So I'm going to show you step by step how to use dimensional analysis. Make sure that you're following every single step every time. These are really easy, the ones that we're going to do today, because they all equal 1. But once they stop equaling 1, they're not going to be as easy. But you need to follow the same steps. Since these all equal 1, you're going to be very tempted to skip steps because 1 divided by 1 is whatever the number is, and whatever the number is multiplied by 1 is whatever the number is. And you guys are going to be tempted to skip steps. But don't do that because you're going to pick up some bad habits. And then once we get to moles, you're not going to be able to recover. Okay, so the first thing that's going to go in your notes, in your Cornell notes on the left-hand side, is equivalence. So as you're watching this video, guys, you can pause and fast forward as needed. So if you need more time to write stuff, you can just pause the video and write and then keep going. So we use these in dimensional analysis, and basically they equal 1. So you can just write the example, 1 foot equals 12 inches if you want in your notebook. This is an example of an equivalent. So 1 foot and 12 inches is the same exact thing. If I ask you to draw a line on the ground that's a foot long, and if I ask you to draw a line on the ground that's 12 inches long, it's going to be the same length. But this is a really important concept that you need to know. 95% of the time, the reason kids don't get moles or dimensional analysis is because they don't understand this concept. When you put one on top of the other, they equal 1. They cancel out and equal 1 because it's the same length. So that you need to put in your notebook for sure. So dimensional analysis is based on the idea that you can multiply anything by 1 as many times as you want, and you won't change the physical meaning of the measurement. So you're going to multiply 27 inches by 1, but in order to multiply it by 1, we need an equivalent that's the same as inches. So 27 inches times 1 foot divided by 12 inches will give you 2.25 feet, and that's the same exact thing. So 27 inches and 2.25 feet are the same thing, so maybe the question required the answer in feet instead of inches, and we multiplied it by 1 to get the same exact measurement. So remember, inches and inches will cancel out. If the problem is asking for feet, we're going to be left with feet. All right. The next thing that's going to go in your notes is canceling. So canceling is going to go on the left. So anything that's on top and the bottom of an expression will cancel. When canceling units, you only cancel the units. So 27 inches times 1 foot divided by 12 inches, the units will cancel out. Inches and inches will cancel out with each other. However, you still need the numbers to work out the problem mathematically. The only time numbers will cancel is if it's the same number. So 12 inches and 12 inches, because 12 divided by 12 is 1. Okay. The next thing is the steps for dimensional analysis. So you can write steps on the left-hand side. These are the same steps that you're going to use for molarity, titrations, all that stuff. Even though these are really easy and they all equal 1, you're going to follow the same exact steps. So step number 1 is write down your given information. So usually they tell you something like given 32 grams of sodium nitrate, how many moles of nitrate in a 125 gram solution. Something like that. So you're always given a number, and that's the first thing you're going to write down. The second step is you're going to write down an answer blank and the desired unit on the right side of the problem space, which is kind of a weird thing to say, but let me see if I can set one up for you on Word really quick so that you understand what that means. So this is what rule number 2 means. You're going to set up your units before you even plug in any numbers. So problems usually look like this. Given 32 grams, how many kilograms? So you need to set up your units, and it makes it so much easier for you to figure out what numbers go where if you do that. So the first thing I want to do is I want this grams to equal 1. So in order for grams to equal 1, I'm going to have to put grams, grams, lowercase, grams here. The desired unit, however, is kilograms. So kilograms is going to go up here. And then this one will cancel out, this one will cancel out, and I'll be left with kilograms, which is the desired unit. So that's what number 2 means. You're just going to set up your branches, and this is what a branch is, and I need to see these for every single problem before you even plug in numbers. Okay, rule number 3 is you're going to use equivalents to cancel the unwanted unit and get the desired unit. And then step number 4, which is a little bit cut off, there it is. Calculate the answer and multiply across the top and divide across the bottom of the expression to work it out. So you're going to follow these same steps over and over again for all these problems. Okay, after steps, we're going to talk about common equivalents. So write common equivalents on the left of your Cornell notes. These I need you to write down in your notes. So these are American units for the most part. And you're going to use them over and over again for your assignment today and throughout the year. Oops, sorry. So I need, go ahead and pause the video, write these down in your notebook, and then we'll move on. Okay, now that you have all those units in your notebook, we're going to start with our first example. So the question is, how many grams are equal to 125 pounds? So we're going to start with the dimensional analysis steps. Step 1 is to start off with whatever you're given. So we're given 125 pounds. The next thing, we're going to create our answer blank. And then we're going to use equivalents to, well, they didn't set up the answer blank the way they should have. Okay, there's the answer blank. So there's the answer blank. We know that we need to cancel out pounds with pounds, and we want to be left with grams because that's the desired unit. So now you need to look at your equivalents from your notes and put in the equivalent that goes from grams to pounds or pounds to grams. So we know that there's 454 grams in 1 pound, so that's our equivalent. So the way you work these out is you're always going to go to the right and then go down, and then, well, I should say you're going to start with the top and then go down. Everything on top is going to multiply, everything on the bottom is going to divide. So the way you work this out is it's a 1.25 times 454 divided by 1. And this is a really easy problem because it's a one-step problem, but sometimes there's 10 steps. And you just keep doing that the whole time. 1.25 times 454 divided by 1 times whatever this number is divided by this number times whatever this number is divided by this number. So that's how you're going to work all of them out. Once you work this out in the calculator, you're going to cancel out the units. Pounds cancels out with pounds. And then you end up with 568. I think we got like 567 in class. But they just rounded up, sorry. The next thing that's going to go in your notebook is metric prefixes. So these are equivalents as well. You should know these from last year. Metrics. Some of you guys already have these in your notes. So for the most part, American equivalents will be given to you. So inches, miles, that kind of thing. Metric prefixes will not. These are just things that you have to memorize. So you can pause the video again, write these down, but I don't like the way these are set up. I'll show you a different way to write them the way I like to write them. You can use either one. Let me put it on the Word document so that you guys can see. Okay, so this is how I always remember it. The way I taught my kids last year was King Henry drank Ucky dark chocolate milk. So King is for kilo, Henry is for hecto, drank is for deca, Ucky is for unit, dark is for deci, chocolate is for centi, milk is for milli. So King Henry drank Ucky dark chocolate milk. And this always kind of helps me remember the metric units. Because I know a kilo equals 1,000, hecto is 100, deca is 10. The unit is always 1, and units are grams, meters, and liters. Deci is 0.1, centi is 0.01, and milli is 0.001. Don't confuse these, because I noticed a lot of kids were writing the units incorrectly. You just have to remember millis 1,000, centis 100, decis 1. So that means that there is... The unit conversion works this way. So if you're looking for how many grams are in decigrams, you can't really do that. Grams are bigger than decigrams. Decigrams are 0.1 and grams are 1, way, way bigger. But the way you can translate that is 1 decigram is equal to 0.1 grams. So like 1/10 of a gram is equal to 1 decigram. 1/100th of a gram is equal to 1 centigram. 1/1000th of a gram is equal to milli. Or you can flip that the other way around, and you can just remember there's 1,000 milligrams in 1 gram. And I'll show you what I mean when we get to examples like this. So we're going to keep going with metric equivalents. A lot of kids, it says many students confuse where to put the numbers shown in the previous chart. It always goes with the base unit, the one without a prefix. So it says write the correct equivalent between kilograms and grams. So remember, kilo is 1,000, and there are a couple of ways to write this. The first one is to say 1 kilogram is equal to 1,000 grams, or 1,000 kilograms is equal to 1 gram. One of these is wrong. And if you look at it and you figure it out, you should see that the bottom one is wrong. Because, again, kilograms are super, super huge. You can't fit 1,000 kilograms in 1 gram. You got to remember the units. Grams are much smaller. You can fit 1,000 grams into 1 kilogram, so don't get those backwards. Same thing with milliliters to liters. It says write the correct equivalent between milliliters and liters. Remember, milli is in the thousandths, and there's 2 options. You can either say 1 liter is 0.001 milliliters, or you can say 0.001 liters is 1 milliliter. And then for centi, you could write 1 centimeter is 0.01 meters, or 0.01 centimeters is 1 meter. In each of these, one of these is wrong. So for this one, the top one is wrong. So remember, milli is a lot smaller than liters. So if they would have said 1 liter is equal to 1,000 milliliters, that would have been correct. But 1 liter is not equal to 0.001 milliliters, because that would be a super, super tiny number. However, 1 milliliter would be equal to 0.001 liters, because liters can't fit into milliliters. So 1/1000th of a liter would equal 1 milliliter. For this one, you should have figured out that the bottom one is wrong. Remember, centimeters are a lot smaller than meters. If this were 100, that would be correct. 100 centimeters equals 1 meter. But this again is a tiny number, just like this one. But 1 centimeter would be equal to 1/100th of a meter. That would be correct. Okay. So there's only 1 metric volume unit that we need to remember. And it's being cut off. And let me pull that down. It's not working. Okay. So it says to find the volume of a cube, you measure the length times width times height. It says most chemicals aren't nice, neat cubes, therefore they're defined as 1 milliliter. 1 defined 1 milliliter as equal to 1 centimeter cubed. So we had the American units and we had the metric units. For metric volume units, it's only the 1. And you have to know that 1 centimeter cubed is equal to 1 milliliter. And remember, guys, pause as you go or fast forward as you need to. Okay, we're going to get into another example. How many grams are equal to 127 milligrams? So again, we start off with rule number 1. You start off with what you're given. Then you set up your units. Oops. So we know that we want milligrams and milligrams to cancel, and the desired unit is grams. So grams is going to be up here, and our answer will end up with grams. So it says our conversion equivalent is here. It says 1 milligram is equal to 0.001 grams. So you put that where the grams are. 0.001 grams equals to 1 milligram. Again, you could do it the other way around, and you can say 1 gram is equal to 1,000 milligrams. If you plug either one of these into the calculator, you'll end up with the same right answer. So you can either do this, 0.00 grams, so 1/1000th of a gram is equal to 1 milligram, or you can say 1 gram is equal to 1,000 milligrams, and it's the same equivalent. Try it out. Put both of them in the calculator and see what you get. You should get 0.1270. You can work out these problems either way. It doesn't matter. You can use this or you can use 1,000 down here. As long as you get the right answer, I don't mind. The last thing we're going to talk about, well, second to last thing, is multi-step problems. So like I said, sometimes you'll have multiple branches, not just the 1 or 2. And this is why. There isn't always an equivalent that goes directly from where you are to where you want to go. Rather than trying to determine a new equivalent, it's faster to use more than one step in dimensional analysis. This way you have fewer equivalents to remember, and you'll, if you have more to remember, you'll make mistakes more often. It says, with multi-step problems, it's often best to plug in the units first, then go back and do the numbers. So, example 3 says, how many kilograms are equal to 345 centigrams? So, we start off with our given, 345 centigrams. Then we're going to set up our units. And here it's telling you that there's no equivalent between centigrams and kilograms. So, this tells you that there's going to be an extra step. So we know we're going to start off with, there is a conversion from centigrams to grams, however. So we know we need these centigrams to cancel out. And then now we're left with grams, but we don't want grams. So intuitively, you should know that you're going to have another gram here. And the desired unit is kilograms, so kilograms should end up here. There we go. So this is still step number 2. You're setting up your units with blanks, and then you go from there. So now you put in your equivalents. We know that 1 centigram is equal to 0.01 grams, and 1,000 grams is equal to 1 kilogram. So you would put 1 centigram here and 0.01 g here, and then 1,000 grams equals 1 kilogram, and then you multiply it out to get the answer. So 345 times 0.01 divided by 1 times 1 divided by 1,000 in the calculator will give you your answer. The units will cancel out. You'll be left with kilograms, and you should have gotten 0.00345 kilograms. Again, you could have flipped this one around. Like this one, I think is easier for most of you guys to understand. 1 kilogram has 1,000 grams in it. You could have also said that 1 gram has 100 centigrams, and you would have still gotten the same answer. Okay, so there's some practice problems here. 0.250 kilograms is equal to how many grams? So go ahead and pause the video, see if you can work it out, and then get the answer. So when you work it out, you should have put 250 because that's your given, the equivalent, canceled out kgs to be left with grams, and the answer is 250 grams. Okay, try this problem out. How many milliliters are equal to 2.78 liters? So pause the video, try to work it out. So your given is 2.78. You want to cancel out liters and liters. The equivalent was 1 milliliter equals 0.001 liters. Or you could have said there's 1,000 milliliters and 1 liters, and you would have gotten the same answer. You should have gotten 2,780. Problem 3. 147 centimeters cubed is equal to how many liters? This is a two-step equation because you need to convert centimeters cubed to milliliters. So go ahead and try this problem out and then look for the answer. Okay, so the first step is you got to use the equivalent. Remember, centimeters cubed is equal to 1 milliliter, and then you have to go from milliliters to liters, which is the desired unit. And you should have ended up with 0.147. Okay, another practice problem. How many milligrams are equal to 0.275 kilograms? Pause the video, try to work it out. So this should be the resulting answer that you got. Okay, one last thing I want to talk about because my kids were getting confused with double units. So I'm going to show you an example of that on Word. On your worksheet, sometimes you have double unit problems. So that means you need multiple conversions to finish out the problem. So this one says convert 50 feet per second to minutes per hour. So that means, sorry, it should be miles per hour. Minutes per hour to miles per hour. So you need to convert feet to miles and then seconds to hours. So we're going to start off with what we're given, just like any other problem. So we're given 50 feet, and my equals is moving. I'm just going to erase it. And then per second. That's what we're given. So now what I need to do is I need to cancel out feet. So if you look at your American conversions, you know that 1 mile is equal to, I'm going to leave a little space here, 5,280 feet. So now feet will cancel out with feet. I still need to get rid of seconds, however. So I need to make it 1, so I need a seconds conversion. So, but I also need to end up with hours. So I need, seconds will end up being up here to cancel out with these seconds. And the conversion that I have on my American units is, I know that 3,600 seconds equals 1 hour. And then that'll give me the answer that I want. So feet will cancel out with feet. This second will cancel out with this second, and then we'll be left with miles per hour, which is the desired unit. So you got to work, and then whenever the unit's like this, you're always going to pretend that there's a 1 down here. And I just shifted everything over. Okay, so it's going to be 50 over 1. So we're going to multiply it and divide it out the way we need to. This is a 1, so I'm going to kind of ignore it. So it's going to be 50 times 1 divided by 5,280 times 3,600 and divided by 1. And that'll give us our answer. So we should end up with 34 miles over 1 hour. And final answer will be 34 miles per hour. So that's how you will work out the double unit questions. So go ahead and go to Echo, download the worksheet, and get started on the problems. It'll be due as you walk in next class at the tardy bell. If you have any questions, you can come in for tutoring. It's not due till Monday. So yeah, come in to tutoring before after school before this is due. All right, see you guys later.